This is a walkthrough of the model for the Sugar Transport BioGraph activity. Starting with the interface, you can see that there are several buttons to set up the simulation. We have set up without barriers, set up with barriers, set up large with barriers, a button to run the simulation, and then buttons to add glucose, which is in the body, and then to drink soda, which brings additional glucose in. The blood flow button causes the glucose to move as if blood is flowing, and then we can also add FD proteins, that stands for facilitated diffusion, or add AT proteins, which stands for active transport. So let's look at this representation. This is a model of sugar being transported from the lumen into the bloodstream by way of the epithelial cell. And so if I edit camera and zoom in here, again, this is the lumen on this side, and then we have a cell membrane, the epithelial cell, the internal of the epithelial cell, and then another cell membrane, and then the bloodstream. So I'll set up with barriers again. And in this scenario, we have these starting little particles. I can run for 50. And you can see that through diffusion, some of these small particles are able to cross the cell membrane here. Whereas if we have these larger particles, they will not be able to cross that membrane. We can add facilitated diffusion proteins, which basically just make this hole a little bit bigger to enable particles to flow through. Or we can add active transport proteins, which will actively transport any one of these particles that touches it from left to right. So let me set up glucose, or actually I'll set up regular with barriers. I will add my active transport proteins and run for 50 and drink some soda. So now these white cubes here are the new glucose. And you can see that they are being transported across the membrane in this direction. Whereas these purple molecules, which represent some other dissolved solid, they can flow across this membrane in either direction. But the glucose is only transported from left to right. If I click the blood flow button, now you can see that the glucose is flowing upward, and this has the effect of essentially continuously reducing the concentration of glucose on the right, which may cause the concentration gradient to change. And of course, what we want to happen in our bodies is to take glucose from the lumen and move all of it into the bloodstream. Whereas if we already have glucose, and we do have some amount of glucose in our bloodstream and we haven't eaten, we do not want the glucose to be flowing from the bloodstream back into the lumen. So we're using active transport to maintain a concentration gradient across that membrane. Notice these data boxes down in the lower left, and that's it for the sugar transport model.